Hello there, welcome to Pre-Cal Lecture 2.6 where we're going to be working quadratic geometry problems. So you will be using pre-printed notes on this one. There's a couple of examples on the front and I think three or four examples on the back. Alright, so let's get to it. So the first example, so we're in section 2.6.1. We're going to go straight into the example problems. It says the perimeter of a rectangular dorm room is 34 feet. Its area is 60 square feet. What are the dimensions of the room? All right, so let's draw a rectangular dorm room here. And we'll just call, doesn't really matter, but we'll call that L for length and this side W for width. And since it's rectangular, you've got another L down here and another width here. So we've got enough information. It says the perimeter is 34 feet. So we've got two L's and two W's. So I'd have 2W plus 2L is equal to 34. Now I can simplify that if we want, divide both sides by 2, and we would have W plus L is equal to 17. Now we also have, we know that the area is 60 square feet. Well, area is length times width, so we'd have an equation LW is equal to 60. All right, so I can, let's say we want to solve for L in terms of W, right? So we're going to do a substitution here. So with this equation, I could say L is equal to 17 minus W. All right, I'm just moving the W to the right side, solving for L. And now we can substitute 17 minus W in for L. So now we only have one unknown. So we'd have 17 minus W times W is equal to 60. So let's distribute the W. It has 17W minus W squared, when I distribute that W, is equal to 60. So let's get everything on one side, set it equal to 0 so that we can solve it. So if I moved the W square over to the right and the 17W over to the right, I would have W squared minus 17W plus 60 is equal to 0. So I just moved that W squared over to the right, made it positive, moved the 17W over to the right, made it negative, and then set all that equal to 0. Okay, well, let's see if we can factor this. We don't want to go quadratic formula if we don't have to. And we know we've got a W and a W. And I know that 12 times 5 is 60 and 12 plus 5 is 17. So how about minus 12 minus 5? Something like that. So if we FOILed that back out, I'd have W squared minus 17W plus 60. There you go. So we know that W is going to be equal to 12 or 5. Okay, so if W is equal to 12, then I know that length is equal to 17 minus 12, which is 5. Okay, and if W is equal to 5, then length would be 17 minus 5, which is equal to 12. So ultimately what it's saying is this room is 12 feet by 5 feet. So it doesn't matter. One of them is the length, one of them is the width. Which is which? Who really cares, right? But it's a 12 by 5 room. Kind of small. All right, the 12 part isn't too bad. I mean, if it's just one person, but the 5 part, boy, that's really skinny. Okay. So let's take a look at our next example problem. That one says a gardener wants to fence her plot into 2 equal rectangular sections. If she has 48 yards of fence and the area of the entire plot is 96 square yards, find the dimensions of the garden. Okay. Well, let me get a new marker here. So let's draw this out. So we have a gardener wants to fence her plot into 2 equal rectangular sections. So we're just going to draw 2 equal rectangular sections. Now I need to give a variable. So let's call the horizontal variable y. And we know that all 3 of these, the vertical is y. We know all 3 of these vertical members are going to be the same since it's rectangular. Now we also have the horizontal. So we know that each rectangle is equal, so this would be x, this would be y. That means this part is x and this part is x as well. Okay, so we just drew the picture and assigned variables to different parts. Okay, so now let's try to get some equations. It says we have 48 yards of fence. That means all of the perimeter of all this fence is equal to 48. Something's equal to 48. Well, how many x's do I have? I have 1, 2, 3, 4. So we have 4x plus 3y is equal to 48. Okay? So I'll work with that in a minute. Now it also says that I have 96, the entire plot is 96 square yards. Well, the width of the plot is 2x. We know area is length times width, so I'm 2x. And the height is y, so 2xy gives us our area, 2xy. 2x times the height y. Okay, and that's going to be equal to 96. So let's simplify this. If I divide both sides by 2, I'd have xy is equal to half of 96, so 48. So we can solve for x or y. It doesn't matter to me, but let's say y is equal to 48 over x. And now I'm going to plug that 48 over x in right here for y. So we'd have 4x plus 3 times 48 over x. And it doesn't matter if you chose to do x as 48 over y, then you would plug 48 over y right here. But now I'm plugging in 4x plus 3 times 48 over x is equal to 48. All right, so that's going to be 4x plus 3 times 48. Well, 3 times 50 is 150. So that would be 144. Is that right? 3 times 48. So 144 over x is equal to 48. Now I want to clear the denominator. Remember, we did this kind of work. If I multiply both sides by x, I would have 4x squared plus x over x cancels, and we have plus 144 equals 48x. So now let's bring that 48x over to the left. We have 4x squared minus 48x plus 144 is equal to 0. All right, so let's see. Will 4 go into 144 evenly? Let me get my calculator real quick. So I don't. Sorry with that. Wasn't really prepared. All right, 144 divided by 4 is 36. Okay, so we can divide both sides by 4 and simplify this to x squared minus 12x plus 36 equals 0. Okay, I just divided both sides by 4 to simplify. Okay, so now let's try to factor. So much easier to factor now. X, and let's see, 9 times 4 is 36. 12 times 3 is 36. 6 times 6 is 36. I think we can get a 12 out of that. So how about minus minus? And I'd have x squared minus 12x and negative 6 times negative 6 plus 36. All right, so x is equal to 6. There's just one solution for x in this particular problem. All right, so now let's figure out what y is. Well, we know that y is equal to 48 over x. So y is equal to 48 over 6, which is equal to 8. So y is equal to 8, x is equal to 6. So the whole garden is 2x times y, right? It's 2x wide and y height. Well, 2 times x, that'd be 12. So it's 12 yards by y, which is 8. So 8 yards. So the reason it is 12 yards is because it's two values of x in width, all right? So 6 plus 6 gives us 12. And then just one value of y there, just one y height, which is 8. All right, pretty cool. All right, you will definitely have something like that, and maybe even something like that on the homework that's got a little hot sauce on it. So maybe stretch you out just a little bit in your thinking, not too much. All right, so if you will go on to the back or the second page of this. Let's see, I don't have the... So the second page, we've got 2.6.2. And this is called using the Pythagorean theorem. Okay, so you've got a picture of the triangle, the right triangle on your notes, right? That symbolizes 90 degrees. And we've got the hypotenuse, which is C, and leg A and leg B. And we know that A squared plus B squared is equal to C squared in a right triangle. Okay, and then to solve for C, we would take the square root of A squared plus B squared. And I said in your notes, that's also called the distance formula. It'd be the distance between these 2 points. This point here and this point here. That distance is C. Okay, so the first problem says that the distance, so just read along with me on your paper, the distance between home plate and first base is 90 feet. What's the distance between home plate and second base? Well, let's draw this out. So we've got as I'm making this video, it's baseball season. Got a baseball diamond, so there's home plate, first base, second base. And we know home plate and first base is 90 feet. And also between first and second would be 90 feet. And we want to know the distance between home plate and second base. So we'll call that C, all right, because that's the hypotenuse of this right triangle. Okay, so C is equal to the square root of the two sides squared, 90 squared plus 90 squared. All right, so a fast way that you could do that in your calculator is just take 90 squared plus 90 and hit the x squared button. You've got that. And then raise that to the 0.5 power. That's the same as taking the square root. It's 127.3 feet. And there you have it. So that's how far it is for if somebody's trying to steal second base, the catcher has to throw from home plate to second base 127.3 feet. All right, the next question says an equilateral triangle has a height of 8 centimeters. Find the length of each side. Well, let's draw out an equilateral triangle. Equilateral means that all sides are the same. So we can just give a variable x to all three sides. We know that the height of this triangle is 8. So now we've made a right triangle. With this leg is 8, this leg is x, and then how much is this leg from the center to the outside? Well, it's half of x. So that distance is half of x. So we've got a triangle with hypotenuse x. One leg is 1/2 x, and then one leg is 8. So I would have x squared, the hypotenuse squared, is equal to 8 squared plus 1/2 x, and that's going to be all x squared. It's not 1/2 x squared. It's the entire 1/2 x in parentheses, that whole quantity squared, not 1/2 out front and then x squared. That's the most common mistake on this type of problem. Okay, so 1/2 squared is a fourth, so we'd have x squared is equal to 64 plus 1/4 x squared. So if we subtract 1/4 x squared from both sides, I would have 3/4 x squared left on the left. 1 minus a fourth is 3/4, is equal to 64. So if I multiply both sides by 4/3, x equals 64. X squared is equal to 64 times 4/3. So I'm multiplying both sides by 4/3 to get rid of that coefficient out front. You can think of flipping and multiplying by the 64. So we'd have x squared is equal to 64 times 4 is 256 over 3. So x would be the square root of 256 over 3. And if you put that in your calculator, you get about 9.24. All right, fantastic. So that's a very common ACT math problem. Okay, the last one for this lecture says, two cars arrive at an intersection at the same time. One drives east while the other drives south at 10 miles an hour faster than the eastbound car. After 2 hours, the cars are 100 miles apart. How fast is the southbound car driving? Okay, let's draw this out. So you've got a car headed east, and then a car headed south. And we know that the distance between the two would be 100 miles after 2 hours. So the eastbound car is, so first of all, this is a distance equals rate times time problem. We want to know how fast, so we want to know the rate, right? So that means rate is equal to distance over time. Okay, so distance, this is a distance, 100 is a distance. So distance would be, time is 2 hours, rate is r, so it's going to be 2r. All right, so it's traveled for 2 hours, right? But we don't know the rate. We just know that the southbound car also travels for 2 hours, and it is 10 miles an hour faster. So it's r plus 10. Okay, r plus 10 is the southbound car. So now we've got a Pythagorean theorem situation. So if we if we distribute that, we'd have 2r plus 20. So the Pythagorean theorem states that the hypotenuse squared, 100 squared, is equal to 2r all squared. Right? You have to square the 2 also. It's the whole thing. Plus 2r plus 20 all squared. Okay. So this will take us a little bit of work here. But what we've got is 100 squared. All right, well, that's 10,000. Is equal to 2 squared is 4. So it'd be 4r squared plus, and then you got to FOIL this out. So it'd be 2r plus 20 times 2r plus 20. Right? So 2r times 2r would be 4r squared plus 20 times 2r is 40r plus another 2r times 20. That's going to be 80r. And then 20 times 20 would be plus 400. So let's combine like terms. So first of all, we need to set this equal to 0. So I'm going to move the 10,000 over to the right. Make it negative. All right, and then 4r squared plus 4r squared is 8r squared. And then we still have the 80r, and then minus 9,600. How did I get that? 400 minus 10,000. Combine the two 4r squareds, and then we have the 80r. We should be able to divide all three of these numbers by 8, because I know 8 will go into 96, so 9,600 divided by 8 is 1,200. So I can reduce this by dividing every term by 8. So that'd be r squared plus 10r minus 1,200. Now, if you don't want to try to factor this, then you can put it in the quadratic formula like that. But this is one worth factoring, because the r and the r is pretty easy, and I know that 40 times 30 would be 1,200. So how about plus 40 minus 30? That's going to give me a positive 40r and a negative 30r, which gives me positive 10r, and then 40 times negative 30 is minus 1,200. So we have two solutions for r, negative 40, right, because negative 40 plus 40 is 0, and then 30, r can be 30. Negative 40 is an extraneous solution because you can't have negative miles per hour here. Okay, so our rate is 30. So the eastbound car is going 30 miles per hour. How fast is the southbound car going? Well, the southbound car would be going r plus 10. 30 plus 10, so 40 miles an hour. All right, I just got that by doing r plus 10 because that was our initial condition. The southbound car was going the same as the eastbound car plus 10 miles an hour. All right, so that does it for your notes. Now, the homework is worksheet 2.6. And it's problems that are basically similar to what we did. I will say that here with number 1, I give you the formula for area of this trapezoid. So you're going to have to come up with an equation using that area formula. So that's a little bit different. I did not, we did not work one exactly like that. And then you've got this, and these are all, everything else is a similar problem to what we worked. So only number 1 is a little bit different, but give it a go. I gave you the area formula, which you would not have to memorize for a test. And I will talk to you on the next one.